Hey everybody, and welcome back to Maths for our brand new term, and it is online learning again. Now, today, woohoo, we're going to be looking at graphs, and we're actually reading and interpreting graphs. So, the first thing I want to do is start with our learning objective, which is I can read and interpret line graphs. Oh, yes, indeed. So, I can read and interpret. So that means by reading, it doesn't actually mean having letters and that we can read. It means looking at what we can see in front of us and understanding what it means. And that is the same as interpret. Okay. So it's working out what the graph is trying to tell us here. Okay. And it's all to do with line graphs. Many of you will be familiar with line graphs. Many of you won't. The key to understanding line graphs is going to be the line aspect. And they are very particular types of graphs. So, first of all, here is my first question. What do you think a line graph shows? Now, you will find that question, okay, on your, how should we say, on your Google form that you're currently using at the moment. Please go back and answer that very quickly. Don't spend too long thinking about it, but what do you think a line graph shows? Okay, welcome back. Right. So what do we think a line graph shows? What do you think, Johnny? Oh, well, I think a line graph shows a graph with lots of lines, but I'm not too sure what a graph is. Okay, thanks, Johnny. Okay, well, let's move on then, okay? You'll all have your interpretation of that is, and we'll look at what a line graph actually is in a moment, because understanding that would help us. First of all, let's move on to the next question. Where might you see a line graph used in real life? Now, again, until you've seen what a line graph is, if you're not sure what it is, this is going to be very, very tricky. So, okay, have a go at answering that question anyway. And I am aware that I haven't shown you any line graphs. However, some of you who are a bit more observant may have noticed there may be some on your actual Google form. I won't say any more other than that. Please have a go answering that question, then come back. Okay, so where might you see a line graph used in real life? Well, okay, this question here, both of these two questions that we've answered previously, we need to look at what a line graph is. So now what I'm going to do is I'm going to jump to the line graphs, okay? And those of you who are more observant would have seen that there would be 4 examples of line graphs on your form. Now, I have some other questions, okay, that I'm going to ask you in a moment. But before I do, I'm going to start by looking at these line graphs. So first of all, let's go back to our original question up here, which was, what do you think a line graph shows? Well, we'll just use these first two. I don't know. It shows a line on squared paper. It's got, yeah, there's numbers on it. Okay. I mean, yeah, that could be it. What about this one? Where might you see a line graph used in real life? Now, this one I can use these graphs to help me if I read the sides of it. Okay, so it gives me some idea of what they might help me to show in real life. Okay, because line graphs actually are very, very useful. And in real life, we use them a lot. Even as teachers, we do as well. Unbelievable though that may seem, we've used them this year already. When we look at, for example, we might look at your scores in maths. I don't want to obviously say that, we're not making a big thing of it, but we do look at it because it's of interest to us and we want to help you with that. So it is something we might look at. Being honest, it is something we do. Okay, so we can use them in real life in many different ways. Now, these are my next questions. And these questions, again, you will see they have 1 and 2 next to them. And you will see questions 1 and 2 on the form under the 2 previous questions that you've answered. So what I would like you to do now is I want you to have a look at on the next below these questions, you will see these graphs. And there are 4 different graphs. What I want you to do is I want you to answer both of these questions. Now they're on separate. There are separate questions on the form. The first question says, "Can you see what they all have in common?" So look at the examples of the line graphs before we define what they are. So can you see what they all have in common? What do they have in common? What's the same with each of them or about them? Also, my second question is, what differences can you spot between the different graphs? So They may all be line graphs, and they are all line graphs, but what are the differences? Okay, and then we'll understand, that'll help us to understand exactly what line graphs are. Okay, go and answer those two questions on the Google form, and then come back and we will carry on. Okay, so first of all, right, let's have a look at this question first, which is, can you see what they all have in common? So let's have a look at some of these line graphs. Now, I'm actually going to present here, okay, because it makes it a little bit easier for me. So first of all, let's have a look. I would say the first thing that you can see in common is, well, there's a line. This starts at 0, but there is a line, okay, and I can see that going there. I can also see this line here. Now, this is curved, and this is straight, a series of straight line, but it's one joined line. Look, it doesn't stop. There's no gap in the middle. It continues, yeah? Can you see that? Okay, and likewise, it's the same with this here. Look, the line continues. The only difference is this is curvy and wiggly and goes all over the place, doesn't it? It's much more difficult to actually read. It looks more like a mountain, but it's continuous. Notice, it starts and I continue along it. Right, okay, let's have a look at the next page. Have a look at the graph, see it. Is that the same? Yes, look, there you go. There may be points where it stops, but it's still one continuous line. Look, it doesn't stop until it gets to the end. So I'm going to call that, yeah, it's continuous, isn't it? It continues. So they're one, and there we go. Here we go. It's curved. All right, but it's still one continuous line. So one difference is that some of them are straight lines, are made of straight lines together, or one, series of straight lines joined together. Some are curved. However, what is the same, or what do they have in common? They're one continuous line from start to finish. Now, the other thing I've noticed is they go from left to right in each case. They start on the left and they go to the right. So let's have a look at the other ones. And yeah, on the left to the right. Okay, left to right. Difference, this one goes up, straight, up, level, up. This one goes down, no. Okay, then up, then down. Okay, look at this one. Another difference, this goes down, then it goes up, then it goes straight, then it goes up, and then it's really steep, okay? And then it goes down. So they can go up and down. That's something in common, okay? But they also, the difference is that then don't always look the same in terms of the line. Also, let's have another look at some of this data as well. Look at the data here. Ooh, look at this. 600,000, 500,000, 400,000, 100,000. That's 100,000 here. Look at that. Wow, that's a huge difference there. And then that's 100,000 because this is measuring population. So the size of, I don't know what population. It could be a town, it could be a village. A village might be a bit too many. But look, here we go. Okay, it starts between 300,000 and 400,000. So, and this is over 1950, 1960, 1970. So that's years. Look, it's 10 years as well as decades. So it's 10 years between each of these intervals here. Whereas this one is all about temperature in degrees Celsius. And here at the bottom, when it moves out of the way, it says time of day. And the time of day, look, 1 hour. That's 2 a.m. to 3 a.m., 3 a.m. to 4 a.m. So this is actually, look at that. So this is actually a temperature graph, and this is across hours. All right, let's go up and have a look at these. This is time again, but this one is 2 p.m. That's 3 p.m. That's 1 whole hour. 3 p.m. to 4 p.m. That's 1 whole hour. So again, we've got time. Oh, and look, that's time as well. So it looks like they're always, something else they have in common is it's always time along the bottom row here, this row here, okay? This line that goes from left to right is always time. And look, there's an arrow. So it's always going from left to right, and it's always to do with time. And it doesn't matter whether that's hours or it's years, okay? It could be minutes or seconds. And then it looks like this one here, this could be different each time. So this could be distance in this case, or it's temperature. Notice this is going up in, what, this is 1 degree, I think, isn't it? Yeah, so 16, 17, 18, 19, 20. Whereas this one is, this is temperature again, but this goes into minus. It's still 1 degree, so -1, -2, or -1, 2, 3. And then this here is population or number of people. It goes from 0 to 100,000. So there's lots of differences and similarities between them, but some of them seem to be common. So let's try and define that very quickly. Okay, let's move on. Right. Line graphs. What do they show? Now, they show the following. Every line graph is a graph that shows changes in data over time. Now, the data is the numbers, should we say here. So this is the data on the left, and it's the change over time. In this case, this is showing the change in population over every 10 years. So how the number of people is changing in, oh, look, sorry, it says here, and here's the title. This chart shows the population of Cornwall from 1950 to 2010. So Cornwall is a place in England, and it shows the difference, okay? So look, it's gone up from 1950 to 2010. Whereas this, the data here is temperature, and this shows the temperature, okay, in degrees Celsius from 2 a.m. to 3 p.m. on a cold day. So there you go. It's showing the change in temperature every hour from 2 a.m. all the way to 3 p.m. And notice this doesn't have to finish here, okay? Doesn't finish at the end of the graph. It finishes here because we're only measuring until 3 p.m. I wonder why that is. I wonder what that could be to do with. Right, so that's one of the things that it shows. It uses line segments to connect data points. Well, connect data points. What does that mean? Well, let's have a look at this one here. So, line segments. So here are the line segments. So, notice each segment, it connects a data. This is the data point here. So this is a separate data. So we know here at this time at 1 p.m. it was, what is this? What's each of these? 21, just over 21 degrees Celsius. Okay. Then if we go up to this part here, which is one, well, it's somewhere between 1 and 2. But if I go 1, 2, 3, 4, I can split that into 4. So that's 1:15. It's 1:15. I can see that this, the temperature there, this is the data. This was now 19 degrees Celsius because look, that's 20 and we know each of these is 1, so that must be 19. Again, if I go to the next one, which is 2:30, right, 1:30, sorry, right in the middle, I can see it's here. So it's 16, 17 degrees Celsius. Okay, so let's look at the last one. And it represents continuous data. Any point on the line has a value. So we talked about it being continuous. So the data continues. There we go. There's the time continuing, and there is the data. Okay. And the data doesn't change in terms of what I mean by that is we don't change from population to temperature. It's always about the population. That's the data. Okay. So we always have these points connected. And the same with the temperature. It continues over time. The temperature doesn't stop happening. Okay. The temperature is continuing. It's always going to have a temperature every day. And notice it continues each hour. Okay, it continues changing. And likewise, the same for the distance. Okay, look, it's continuing the distance. Okay, there it is. And it is changing. The time is changing. It's continuing, but the distance, okay, that Alfie and Chen walked in an afternoon. Okay, look, they're still walking. They're continuing to walk. Okay, even if they have a break or a rest. Okay, and they had 2 breaks, where I think we can guess where those are. Okay, I'm going to stop this video here, okay, just to stop it there. And then what I want you to do is I want you then to go to the next video, okay? It seems a bit strange, but please do that, okay? Thank you very much.